This mini lecture is about the designation of cis and trans isomers to ring compounds. So let's imagine that we've got a ring and it's flat and it's it's sticking in and out of the plane of the screen. So these are trying to show that this is coming outwards. The F and the CH3 then are going to be on the same side. They'll be both below the plane of the ring, whereas in the trans isomer the F will be down and the CH3 will be sticking up. Now, because there's no rotation about this bond, what's going to happen is that these are going to be considered to be different compounds, and if they're different compounds then they need to be named differently. We can also represent these in two dimensions by putting the ring in the plane of the screen and then showing the F and the CH3 sticking out using these wedges. So these wedges are showing that the F and the CH3 are sticking outwards from the screen. This dash here is trying to show that the F is inwards while the CH3 is sticking outwards. So if we're trying to show cis, the way we can show it is we can show two wedges trying to show that they're both sticking out in the same direction, or two dashes showing they're both sticking downward in the same direction. In the case of trans, it'll one be up and one will be down. Alright, let's do an example. If you were asked to draw cis and trans isomers of 1,3-difluorocyclopentane, for example, what you would do is draw the 1,3-difluorocyclopentane with no stereochemistry, and then what you would do is show the trans with one F sticking up and one F sticking down, and it really wouldn't matter. This F could be sticking up and this one could be sticking down, but one has to be up and one has to be down for trans. And for cis, you draw it with the F sticking up and the F sticking up here, and you could also draw the F sticking down and the F sticking down here. That would be cis as well. Now when you get to a case like this, and I'll do this one on the page here. This one is 3-ethyl 1-iodocyclobutane. Try that again. So you've got a cyclobutane ring, and we're going to we'll put an iodine up here, and we'll put an ethyl group down here. Now we need to draw the cis and trans isomers. We'll draw the trans first. Now trans, what I'll do is I'll put the I sticking up like this, and now I'll have the ethyl group so the I is sticking back, and now the ethyl group will be sticking upwards. Now when you're showing the ethyl group, it's two lines here, but it's only the first line that actually has stereochemistry, because what we're trying to show is that relative to this ring, this is sticking out, but the rest of it is just going to be attached to that bond, and all we're trying to do is just show the disposition of this bond right here. I don't need to show any dashes or wedges or anything on anything connected to that. So this one would be trans. The cis, I'll draw the I sticking back again, but now I will draw the ethyl sticking down as well. And again, all I'm interested in is just showing the disposition of this bond. And this one is the bond that's going to be sticking down. Since they're both sticking down, that makes that cis. Well, let's look at another one. Let's say 3-isopropyl. Now 1-nitrocyclobutane. Alright, so we do the same thing again. I'll put a nitro group up here. I'll put an isopropyl group down here. And then we draw our ring. I'll draw the nitro group sticking up this time. And I will draw the trans isomer first, so I'll draw the isopropyl sticking down. And again, this bond will be the one that will show the stereochemistry. Then I'll just have two methyl groups attached to that C there, which is this C right here. I'll do the NO2 sticking out here. And this one will have to be the same, have to be sticking down as well. I'm going to make that cis, so this one will be cis, and this one will be trans.